We can now begin to review all default bonded contacts. To enter contact review, you can double-click on the bonded contacts condition in the physics tree, or you can navigate to the physics group in the simulation tab and select review. For our example, we'll click on the default solid-solid contacts. From the contact review tool, we'll be able to view and modify contacts in a few ways. First, let's cover how to focus contact review to specific bodies. We can focus on one body by selecting the primary button in the HUD and then selecting the body. For our example, we can see that there are 4 contact pairs in the assembly. If you select the main forward mount, you'll notice that the contact pairs reduce to 3 and only include contact pairs for the main front mount. We can take this a step further by selecting a secondary body, which will focus contact pairs to only contacts between the primary and secondary bodies. To do so, click on the secondary body option in the HUD and select one of the links. The contact pair is reduced to only one now, which is the contact between the main forward mount and the link. Note that the same thing can be done with face selections instead of body selections by clicking on the face options in the HUD. Now, let's make a contact modification with this contact pair. Hover over this information button in the HUD. It informs that we can select markers of individual contact pairs to modify the contact type. Let's follow the directive and click on the marker for this contact pair, which is a circular marker that will be located at the contact location. Clicking it will change the color of the marker and the highlight of the contact faces will darken. We can confirm that we have selected the contact pair as it will read one contact pair of 1 is selected in the HUD. Moving on, we have several options to choose from here. We can modify the contact to be a sliding contact which has additional modeling settings. We can change to a joint contact, but note that the contact pair must consist of collinear cylindrical faces or coincident spherical faces. Otherwise, the contact will default to fixed. We can change to bonded, which won't do anything to the contact since they are already bonded by default, but you will be able to group them as bonded contacts separately. Finally, you can change to the prevented contacts to ignore them. For example, let's select prevented contacts. The contact pair will now be prevented and shown in the contacts tree. You can double-click on it to view it or modify it. Let's undo this by right-clicking on the condition in the physics tree and deleting it, which reverts it back to the default bonded contacts group. Open the Contacts Review tool again and let's look at some other features. This time, click on the arrows on the HUD to expand other options. Here, you'll be able to do 2 things. The first thing is, you'll be able to change contact face grouping. Currently, we are grouping by bodies, which has the least amount of contact pairs. This makes modifying contacts easy, but applies the changes to all faces of the body. If you want to assign changes to tangential faces only, you can click on Group Tangent Faces. Doing so groups contact pairs by tangential faces instead. We can take it down one step further to No Grouping, where all contact pairs will be available individually. This provides the most amount of control over contact pairs across assemblies, but as you can see, can substantially increase the contact pair count. Lastly, for the Contact Review tool, let's look at the Detection Distance option, where you can set minimum and maximum limits of the tool to detect contact. For example, let's zoom in to the link we've been referencing and select the primary and secondary bodies like before. We'll see that with the default detection distance of approximately 5.2 millimeters, we have 49 contact pairs with no grouping. Let's now reduce the distance to 3 millimeters and click Enter. You'll see that we have reduced the number of contact pairs. Let's revert to 5.2 millimeters and we'll see the contacts appear again. The last thing we'll cover is how to assign contacts through the Structural tool. Open the Structural tool and click on Contacts. Here, you'll be able to select a contact pair. Again, let's zoom in to one of the links and let's select a primary surface on the main forward mount. For example, this round. Now, click on the Select Secondary Surface or hold Alt and select the adjacent round on the link. Here, we'll be able to choose from the contact options we reviewed. Let's select Idealized Sliding and accept. The contact will now appear in the physics tree. Note that you can also create hinge joint connections as we did in the bolts module. Now that we reviewed contacts, let's clear any created contacts for example, and let's assign contacts applicable for our case study. Let's open Contact Review and begin to assign some sliding contacts. Let's switch to No Grouping to select individual surface contact pairs. We'll start at the aft mount. Let's enable primary face selection in the HUD, and let's click on the aft mount upper surface. Now, we can select the bottom surface of the upper mount to isolate the contact pair. However, we can see that only one marker is centered while the rest run along the edges. That is because as we hover over the markers, we can see that these contact pairs include the upper mount rounds. We'll ignore these and select the center marker, which should be the contact pair of the main faces. The markers are placed at the geometric center of each contact pair, so you can visually locate contact pairs. However, if it is difficult, you can always select the secondary face to narrow down the options as you can see here. Now, click on Convert to Sliding to update the contact pair. Let's repeat this on the forward mount. Click Escape or an empty space to reset our selection. Now, click on the upper face of the forward mount and select the center marker that represents the contact pair for the main large faces. Click on Sliding Contacts again. Now let's move on to the front mount links. Here, we'll include all individual contact pairs. So let's switch back to Group by Body and select the two markers for the link contacts. We'll now click on Sliding Contact. Notice that since multiple markers are selected, a contact group is created for this case. We can see the remaining contact pairs in the default bonded contacts group are for the upper mount. If we switch to No Grouping, we'll be able to see that the remaining contacts are pairs including rounds that we ignored earlier, so we'll ignore them all again. To do so, simply click on Exclude from Contact Detection. We're now ready to solve, but first, let's review our changes. Under Contacts, you'll see that we still have the default bonded contacts group, but if you double-click, you'll see it is now empty. We also now have a sliding contacts group, which includes the upper mount to the rear mount contact, the upper mount to the forward mount contact, and the forward mount to the links contacts. We also have the prevented contacts group for all the ignored contact pairs. Now, let's click Solve. Note that in this solution, we'll have bolt idealization, bolt preloads, sliding contacts, and all of the original physics conditions. The last thing we'll discuss for contacts will be options within sliding contacts. Pause the simulation and double-click on the first sliding contact we created between the upper and rear mounts. You'll notice that we can switch to frictional. Idealized sliding allows frictionless contact with no separation. Frictional contact allows frictional contact with separation. In the Explore stage, friction coefficients are ignored. However, if you enter 0, you'll be able to enable frictionless contact with separation. This allows us to capture an extra level of accuracy. Let's click Enter and repeat on the sliding contact between the upper and forward mounts. As we do this, notice that the name of the contacts update from sliding contacts to frictionless contact. With this, we are ready to solve again. Let's click Solve and start the solution. At this point, we added a great level of detail to the model, and we are capturing a greater part of the actual in-service conditions for this load case. Therefore, the solution will take a bit longer than the initial solution with a single part. So let's fast forward to the completed solution. We can now see the completed solution, and we can also see the differences in results between each step we took towards more detail in the model. The next step in refining the solution would be to switch to the refine stage, which we will be covering next.